All right, good day, and welcome back to Everything Mathematics. And today we're going to be looking at, or we're continuing our series on algebra. And today we're going to be looking at division of algebraic terms. So again, if you followed up from yesterday and today, firstly we started with addition, then we went to addition and subtraction, then we went on to multiplication, and today we are at division. And division is, again, like multiplication, it could be a little abstract, but I will just show you one of the easiest way to deal with division of algebraic terms. And then later down the line, we're going to look at more complex one. And maybe this is something I should have said since Tuesday when I started looking at basic algebra. But everything I'm doing here is basically a build up to the laws of indices. When we do the laws of indices, hopefully some of these things will make even more sense. Hopefully. Right. So division works like this. So supposing we have 9a squared, and we want to divide that by, let's say, 3a. When it comes to division now, it matters the term that you are eliminating with the term. So when it comes to division, you cannot cancel two terms that are not common or two terms that are not the same. So when I'm dividing here, the easiest way to look at it is this way. I usually like to teach children how to expand. So I would say, okay, 3a squared is basically the same thing as 9 multiplied by a multiply by a. I think that makes it a lot easier. Usually when I show them this, most of them pick it up, but everybody usually say, ah. So yes, when they see that way usually, but of course there are many other ways to look at it. When we look at the laws of indices, you will see that maybe even that approach could be easier, in which you just realize, oh, same base, so you just subtract the powers or blah, blah, blah. You learn that there. So then you have the bottom is the same as 3 times a. And from here, just a matter of elimination. So a cancels 1a, and then we say, okay, 3 could go into itself 1, and 3 could go into 9 3 times. And once we do that, we just pay attention to what is left. In this case, it's just 3a. And that's it. Basically, that's it. Good. So basically, that's how we go about solving those types of equation. Let's see if we could do another busy example. So another scenario again, we could have something like what? 32b squared, and then we have what? 32b squared, let's make it a little more intricate, c cubed, and let's say we're dividing that by 8bc. Again, just looking for simple ones. So at the top here, we just, again, let's distribute, or let's expand. That's 38 times b times b times c times c times c. That's all at the top. And at the bottom, we will have basically 8 times b times c. This c, let me put that in a different color. So this 1c could cancel this 1c, this 1b could cancel this 1b, 8 could go into itself once, and 8 could go into 32 4 times. So everything in the bottom cancel out, technically, so just at the top we're looking at. So this will give us a result of what? So 4 for sure as a number, and the letters, now we have 1b remaining, so that's b. We have 2 c's remaining, so that will be c squared. And that's basically the concept behind it. I think it's rather straightforward. So let's see if we could simplify a few. So simplify. Let's start number 1, 2, 3. So number 1, let's say we end up with what? 18x cubed y squared divided by, let's say what? 10x squared y squared. Then here, let's try another one. Supposing we have something like 40 p divided by try these 4 busy ones at the top. Yellow have to see. At the top, we will end up with what? And at the bottom, we will end up with 10 times x times x times y. Yep, that's what we learned. Okay, let's hope this work out and let's hope this video come out, okay? So here we could easily cancel the y. So y cancel y cancel y. Then how many x we have here? 1x cancels 1x cancels 1x. And in terms of the number, we could look at a multiple or a factor of these two numbers. Here we have 2 could go into 10 5 times, and 2 could go into 18 9 times. And I think that's as low as we could go. So the answer here should be 9/5. And we have, let's see, yeah, only one x remaining. So 9/5 x. And that's as low we could go. Here now, let's see, we have 40 multiplied by p. There's only one p multiplied by 4y. So y times y times y times y, all divided by 22 times y times y. When we learn the laws of indices, believe me, this will be so much easier. All right, so from here now, we just cancel y's. So this y could go with this one y, and this one y could go with this one y. Let's see what else could cancel. There's no p to cancel, or the 22. So we could look at 2 again. I think 2 is the biggest number. Let's try 2 first. 2 could go into 22 11 times, and 2 could go into 40 20 times. And yep, 11 is a prime number, so there's nothing else that will break that down for sure. So that leaves us with 20 over 11 p y squared. Yep. And the last one, should be able to see that off the bat, will be p times 3 times p times p all over p. Yeah, it's a pretty straightforward one to end up there. So 1p cancels 1p, and that will be equal to what? That will be equal to 3p. Yeah, that should do it. So that will bring us to the end of today's video. I hope that was clear enough. If it wasn't, of course, feel free to leave a question in the comment section below. And as always, you take care, and until the next one, see you then.